Hey, what's up? I'm Davis Ford. This is JupyterCon 2020 and my talk, Creating JupyterLab Extensions Faster. So my name's Davis. I'm a principal software engineer at Capital One. I live in Fairfax County, Virginia with two dogs, Taco and Roxy, and my wonderful girlfriend, Amanda. If you play Warhammer, you might know me from AOSreminders.com. It's an open source project that I run. We've got about 30 contributors. Check it out. It's a fun time. Everywhere else on the web, you can find me by looking for daviseford.com. So I'm on the ML Tools team at Capital One. Basically, we do a lot of things around machine learning model governance and workflows and distribution and visualization. It's just a lot of smart people working on machine learning problems. We work a lot with Anaconda, NVIDIA, and Dask. So what brought our team to JupyterLab Extension specifically? Well, before we were doing most of our work through websites, but starting up websites carry a lot of burdens. You know, you're trying to tackle the actual problem over here, but there's all this stuff to worry about. And we really like the idea of just a JupyterLab extension that's kind of self-contained and you just give it to users. Why else? Well, for me, it's the sweet mullet stack. That's my euphemism for having React up front and Python in the back. On top of that, JupyterLab is pretty available on all of our images and clusters. The philosophy of running it on your own machine aligns with what we want. So around the start of this year, we really dove into pushing JupyterLab to both our team and other teams. But as we found out, it wasn't always that simple. The number one question I've gotten is, do I really have to install Conda? User education around Conda and getting people set up with Conda is actually one of the toughest parts of onboarding them into the ecosystem. There's not a whole lot of externally facing examples in the developer documentation, so it's really hard to get a rookie developer to get their feet wet and to get them interested in learning more. By the way, thanks for using TypeScript. It's amazing. I love using your fully typed libraries. Speaking of that, what's the development experience like? So the good parts, like I said, TypeScript. I love TypeScript. I advocate for TypeScript. Thank you so much for using it. All of our Python people are super happy about using Tornado on the back end and all that entails. And obviously our React people are super happy about the UI. There is some rough stuff. Number one, the slow build times. It takes a long time to see your changes reflected whenever you do anything in JupyterLab. And that's tough. And even with Cookie Cutter, it takes a long time to get a deliverable project going. We'll talk more about that in a minute. It can be tough to keep your versions and dependencies all aligned. You're going to have to pin them and then be very careful when you're upgrading to the newest version of JupyterLab. You're going to have to make a decision as an organization as to when you're going to update and how you're going to roll it out to users. So what are some lessons that we've learned? Always pin your versions, not only for reproducibility later, but also because it cuts down on the solve time. Reduce the number of channels that Conda is looking for by using Conda meta channel. And install Mamba. Let's jump into Mamba. So Mamba is the Conda package manager re-implemented in C++. It does one thing and it does it well. It solves environments. It crushes Conda's performance. But there's this weird thing and a little bit of backstory. We have this setup script that creates a Conda environment, installs the server and lab extension and links them and builds JupyterLab. It takes about 5 minutes. And obviously Mamba jumps out to a fast start. But when we go to install the server extension locally, a Mamba generated environment takes a really long time versus a Conda one. So I was interested in all the permutations of the different package managers, and so I decided to run my setup script with all of them, and it turns out Conda and Yarn is the fastest. But an asterisk on that, I think Mamba really will be faster, and there's some weird bug. One thing is for sure, don't use NPM, it's super slow. So we've got a few extensions under our belt now, and we're kind of talking about it as a team, and we've noticed that we're getting some outside attention. Other people want JupyterLab extensions. So we decided to split up and start consulting with other teams and other projects to gain experience and help deliver things. We get a ton of experience from this, which is really great. One side effect though is that some of us end up feeling like we're kind of developing on an island. We're a little more separated, we're working on different projects, different teams. So we decided to get back together and talk about what we've learned about JupyterLab extensions. Can we glean anything from this? And what emerges from those conversations is a set of best practices that we refer to as JLab Scaffold. This is the repository that we offer to developers within Capital One when they need a JupyterLab extension. We've got a lot of great features out of the box, but most importantly, extremely thorough documentation. Great setup scripts, great dev scripts, and, in my opinion, a great approach to tackling the different problems within JupyterLab extensions. One thing I'd like to talk about is the context provider. This is how we facilitate communication between the JupyterLab libraries and React. Let's dive into it. If you don't know what context is, by the way, that's okay. It's a global variable that the React app can access from anywhere. So we've got these great JupyterLab libraries that we really love. We use them. They're much more powerful than a lot of things the native web browser can do. Inevitably, we end up writing these kind of wrapper classes around the libraries to help us do various things. We end up aggregating all of those classes in like a main JupyterLab class, which we inject into our React app widget in the activate function. Once that's injected, our context kind of acts as the communicator or the facilitator between our object-oriented JupyterLab side and our very functional, in 2020 with hooks, React side. Okay, so why did we choose a context? Well, let's talk about how React works. First of all, you've got a parent component, and that parent can have children. The parent can pass data down to its children. It's a parent-child relationship, okay? So the way a React app usually is structured is you're going to have some data in the parent component that the rest of the application will want access to. And that parent component will do a great job of passing it down to whatever child components need it. And those components can react to the data. That's why it's called React, by the way. So we can see we're just passing some information about the user through to the components that need it. Nice and tidy, right? Well, let me show you a downside of this. Let's say our user just subscribed. Okay, well, we're going to update the state, obviously, in the parent component. Then the parent component is going to tell all of its children, hey, we just subscribed. Look at how many children don't really care if we're subscribed or not, but they have to pass it on so that other children get access to the information. This is fine for small applications, but in a large application, you're going to end up with some weird spaghetti code. Don't do this. It's called prop drilling, and it's really bad. What we want to do instead is take that information in our state and lift it to a global context. The fact that this is global will allow our child components to access information they need without disturbing anyone unnecessarily. So you'll notice we've wrapped our entire React app in a provider now. That provider will give us access to the context. So we've got a better, cleaner pattern now. Individual components can ask the provider things without bothering anyone around them. And this is pretty nice. It works pretty well. We only tell the child components that are concerned with things what's going on, and we don't bother anyone else, right? Wrong. Do not store frequently changing data in context. It will lead to horrible performance problems. Basically, whenever you change data in your context, you're going to re-render all child components. Well, that's your entire React app. Don't do it. But we do feel confident putting our JupyterLab classes in context because they never change. They're static methods. This is a great use of context. If you don't know React or if any of this looks unfamiliar, don't worry. Here's a sample React component that I've set up. It's really simple. It's a button that says click me. And when you click it, it logs hello. And I've gone ahead and I put it on the main app here. So I'm clicking this. All that's doing is logging to the console. Well, what I want to do is open the README of this repository. So how would I do this? Well, first of all, let's get our JupyterLab context going here by using our use JupyterLab hook. Don't know what a hook is? That's okay. And then in our little handle click function, all we're going to do is we're going to access that context, and we're going to use the file method, and we're going to open a file, markdown file, that is. We know that we have to pass a string through. And I also, this is fully typed, by the way, which allows me to do this. I know that I want to split to the right when it opens, just so that I'm still looking at my main application and the documentation. One other thing I'm going to do is change this button text because watch mode can take a while. Sometimes you need to wait like 15 seconds, 20 seconds for your changes to be reflected. So what I like to do is change a UI element so that I know my changes are reflected. And there we go. So when we hit ready to go, we're going to have our README file opened to the right just like we wanted it. Now I know what you're thinking. Why not just use Cookie Cutter? Okay, Cookie Cutter is amazing, but it doesn't get a developer to a place where they can deliver an application within a sprint. It just doesn't. So we have to get that time to market down. So I came up with this tool kind of side at desk. I wrote it for myself and then it expanded to become useful for a whole lot more people. Basically, this pulls down the boilerplate repository, configures it with some details about your project, and then sets it all up for you, including your conda environment and everything. You ran yarn dev and now you're here. You can see that we've got our app on the left as well as in the launcher. This heading will be whatever you named your project, and from here you can pretty much just dive in. We've got demonstrations of how we use Redux within the application. This state is persisted if you reload the page, by the way, which is pretty cool. We have these signals demos, which people really like. So one is showing that we can access the Redux store from a separate widget and subscribe to changes in it. And another is we can open multiple widgets and have them share common values. We've got a working server extension where you can send sample requests, even a bad request that it'll yell at you about. And then finally, in-browser code editing, where we're just going to open this file that's governing this React component, and we're going to update it and save it, and we'll be able to see that change reflected over here. So there we go, the update is live, it looks great. So what's up next? Well, we're going to continue to add lessons into the code base as we've been doing. We want to keep introducing and educating new developers within Capital One. All right, I'd like to close this talk out with some constructive suggestions for the JupyterLab team. The number one suggestion is just more examples in the documentation, externally facing examples, just showing simple things like how to signal across widgets or how to open files using the command registry. Anything like that would be really great to get developers going out of the gates. I know that there's a couple curated lists of lab extensions. I'd just like to see more of them. This could be totally a personal issue, but I can never find the individual change logs for each individual package. That could totally be me. If it is, I apologize. If it's not just me, that's me raising the issue right here. Last of all, 2020 has been rough for everyone. Keep up the great work. I've really enjoyed using your software, and thanks for letting me do it. I also want to acknowledge I couldn't have gotten here on my own. I'd like to shout out a lot of people within Capital One that made this possible. Travis Smith, LL Lee, Bryant Sue, Brian Blocker, Ryan Brummer, Gil Forsyth, Mike McCarty, Joe Wolf, Ryan Soley, and Will Franklin. Thanks, and have a great day.